A working AI tool server in just 6 lines of code. No complex routing or protocol handling required. We'll implement the standard FastMCP pattern, creating a server instance, exposing a Python function as a callable tool with @MCP tool, and running it with either STDIO transport, default, or HTTP for web access. You'll see how the decorator automatically handles serialization and schema generation while keeping the option open for CLI execution or integration with frameworks like FastAPI. From FastMCP, import FastMCP. MCP equals FastMCP, my MCP server. @MCP, tool. Def greet name, SDR. Return hello, name. If name equals main. MCP, run. This demonstrates the *** decorator-based RPC pattern ***, where Python functions become remotely callable tools through simple annotations like @MCP tool. The framework treats decorated functions as self-contained endpoints, automatically generating schemas from type hints while preserving native Python syntax. The distinctive aspect is how it abstracts transport concerns, allowing the same tool definition to work across STDIO, HTTP, or other protocols without modification. The pattern works by using decorators as metadata markers that trigger runtime introspection. When you apply @MCP tool, the framework registers the function, validates its signature, and makes it available through the configured transport, defaulting to STDIO for local use or HTTP for web services. This design keeps business logic clean while enabling features like CLI execution, fast API/Starlet integration, or composition of multiple servers through the same interface. This approach reduces RPC boilerplate by handling serialization, validation, and protocol compliance automatically. It's particularly useful for AI integrations, microservices, or scenarios requiring exposed functionality with minimal transport code. The trade-off is framework dependency, but the benefit? Consistent tool exposure across transports with optional features like custom routes and resource sharing makes it practical for both simple scripts and production systems. The server can be run programmatically via MCP, run, or through the FastMCP CLI with the same tool definitions working in both cases. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI callable tools with default STDIO transport. It bridges Python functions to AI models through decorators, handling serialization, validation, and execution while supporting HTTP and SSE transports for web services. The server can also be managed via CLI or composed with fast API/Starlet apps for complex deployments. MCP equals FastMCP, my MCP server. Initializes the FastMCP server instance with STDIO as the default transport. The server name parameter is optional and primarily used for debugging context, while HTTP transport is recommended for web services. This instance becomes the central registry for all AI callable tools and resources, with support for composition with other servers via the mount method. @MCP tool. The @MCP tool decorator exposes this Python function as an AI callable endpoint in FastMCP. It generates an open API schema from type hints and doc strings, handles serialization/deserialization, and routes calls over the default STDIO transport or optional HTTP server sent events transports. This is the primary pattern for creating tools that AI models can discover and invoke, with built-in validation and automatic registration in the FastMCP server. Def greet name, SDR. defines a strictly typed tool function for FastMCP's RPC system. The name, SDR, parameter, and SDR return annotation create an explicit interface contract that FastMCP uses for automatic validation and schema generation, while enabling IDE support and static type checking. This pattern ensures predictable behavior when the tool is called by AI models or other services.
Return fhello, name.
This f-string dynamically inserts the name parameter into the response template. The pattern enables flexible output while maintaining consistent formatting, a common requirement for AI tool responses where predictable structure improves parsing reliability.
If name equals main.
Standard Python entry point guard that prevents MCP, run, from executing during imports. The server defaults to STDIO transport, but supports HTTP for web services and SSE for streaming, with HTTP being the recommended production option.
MCP, run.
Starts the FastMCP server with STDIO transport by default, exposing all @MCP tool-decorated functions as AI callable endpoints. The server supports HTTP for web services and can be run programmatically or via CLI, with optional composition of multiple servers. Standard entry point pattern that enables tool discovery and execution. FastMCP tool registration pattern. The @MCP tool decorator exposes Python functions as remotely callable endpoints, with FastMCP handling schema generation, transport, and serialization automatically over the default STDIO transport. Watch out, tool names must be valid Python identifiers, while server names are optional and support any string format. Key takeaway: this pattern eliminates RPC boilerplate while maintaining compatibility with HTTP, SSE, and web framework integration. Part 3 of our FastMCP 2 series. Next, we'll cover server composition and custom routing.
The same decorator that exposes a function to the network hides the network from the function.